Okay, welcome back to our last lab exercise number 3 in this mini ARP class, where I'm going to show you how you do discovery leveraging the ARP protocol. Okay, so we're going to do a couple of things here. Again, I'm using a Windows machine, and so the tool that I'm going to show, I don't believe it's available for Mac or Linux, but there are other tools like Nmap and so forth, and I'll put a link to some of those tools in the video description. But we're going to use something called Colasoft, and so without any further ado, let's take a look at this. So I'm going to close this down. And I'm going to start something called Colasoft, and this is called the Colasoft Mac Scanner. There we go. So you can see it up here, Colasoft Mac Scanner. Now this is a free tool for those of you who use Windows. You can do a web search, but I'll put a link in the description as well. This is free, however you have to put up with a little advertising, so I'm just going to get rid of that. Now, how does this tool work? This is actually very interesting. So you can see, first of all, that the tool has figured out what the network or the subnetwork is that my machine is currently in, and it's put that network in the local subnet box right there. That's a good starting point. Now, the other thing I'm going to do here for demo purposes is I'm going to start up Wireshark. Okay, now I'm going to use Wireshark to sniff all of the packets that are coming out of my machine so I can observe what it is that Colasoft is doing. So I'm going to pick my Ethernet interface here. I'm going to start capturing. And what I'm going to do is I'm going to filter for ARP messages. Now, we might see some ARPs here that are going on because I'm running other software in the background and so forth. So yeah, we see some ARPs going out. These are broadcasts. These are requests that might be happening on my network. That's fine, right? We can just let that happen. Okay, so back up here on the Colasoft Mac Scanner, I'm going to ask this program to now start a scan. And I want your eyes to kind of go to the bottom here. You're going to see it works like a war games dialer. It just literally is going to go through all 255 addresses that are part of this subnet, and it's going to ARP them. Okay, and then it will record up here in the screen what it has found. All right, so let's go ahead and get started. So you can see we're already at address 43, 44, and this will continue to increase. Now, any answers we've seen are showing up right here. Okay, so this is pretty cool. We're starting to get all of these things that exist on my network. The other thing that's pretty interesting is while it's sort of working through this, and we'll see it'll finish pretty soon. It's at 200 of 255. The other thing that this causes, of course, is that your ARP cache gets very big because everything that exists out in the network has been found, well, at least hopefully everything, and that's also gone into our cache because we're just asking, who's got this IP address. So let's go here and type CMD. Now, I'm not going to do the elevated version. I'm just going to go to my regular command line here, and I'm going to say ARP TAC A. You saw this in the first lab exercise. I'll make this window a little bit bigger. And if I do that, you can see now, look at all of these entries, right, that are dynamic in my ARP cache. They weren't there when I did lab exercise number 1, right? It was a much smaller list of items. So clearly additional things have been found. Okay, so very good. So we get a nice report here, all the IP addresses, what their MAC addresses are, the host name if it's available, any work groups that they might belong to, and then this tool has also looked at the first 3 numbers like D052A8 right here, and it says, oh, I know who does that. That's Physical Graph Corporation. They own that OUI. And so it's telling us who the manufacturer is. So we see some Synology equipment, Apple equipment, etc., etc. Pretty nice. Now let's go back over here to Wireshark. And if we look at how this happened, I'm going to stop the capture so it stops moving. And I'm going to scroll sort of back up the packet capture list. And you sort of see what's going on here on the right-hand side. Let me just go back up here. Right, there we go. So you can see that it just sort of started going down 3, 4, 5, 6, right? 8, 9, 10. You can see it just literally hit every single address doing an ARP request. If you look at any one of these and expand this out a little bit, we'll close this up, we can see that it says ARP request. So it's just simply trying to find out what MAC address exists at that IP address. And that literally cycles through all of them. Now, some of them did answer. Okay, some of them did answer. So let's do this. Let's take the opcode request. This is kind of a cool thing you can do in Wireshark. We're going to right click and we're going to say apply as a filter and not selected. So we don't want requests. Okay. And you can see Wireshark has created a nice filter syntax here. And so these are all the answers that we got. So these are all now responses or replies. And this will, again, identify all those systems. And these two lists should align, okay? So we see, yeah, there's .7, .2, .16, .1, .20. You can see they're all aligning perfectly here with what the Colasoft tool was doing. So hopefully this gives you a good peek as to what goes on and how this tool does this. Again, this is available for Windows. You can just search for the Colasoft Mac scanner. It's absolutely free, but I will put a link. And if you want to do this on your non-Windows machine, on Mac or something like that, or Linux, then you would use Nmap. And I'll link to some information on Nmap at the bottom of this video as well. All right. Hopefully you found this interesting and it expanded your knowledge on using ARP to scan a network. It's pretty cool stuff. Thanks for watching.